Right, good morning everyone. So welcome back to revising for our end of year exam for Sec 1 Lower Sec Science. Now this will be the first video for chapter 1. There will be two videos. The first video today will focus on the apparatus used in the lab, including the Bunsen burner. The second video will focus on variables in an experiment as well as the accuracy and precision of results in an experiment. So let's get started with the first video. So we are looking at apparatus. And the first apparatus you need to know, of course, is the Bunsen burner. The Bunsen burner is a commonly used piece of apparatus to heat up substances in the lab. So there are a few parts to the Bunsen burner which you need to know how to label. The very first part is this part. This is the gas tap. We need to switch the gas tap on for gas to enter the burner itself. To switch the gas tap on, we basically lift the flap before turning. So we have the gas rubber tubing. So it's the rubber tubing to transport the gas to the burner. Now the Bunsen burner always has a base. So the bottom of the Bunsen burner is known as the base of the Bunsen burner. And now we move to the vertical portion. Now the vertical portion is called the barrel. Okay? Now the barrel is basically a chimney-like vertical structure which transports the gas upwards along with air. We need air, specifically oxygen in the air, to burn with the gas that comes out of the gas tap. That burning creates the flames that we need. Now, at the bottom over here, this is our focus now. We need to know how to label these things. First, we have the movable collar. The collar is the metal piece which can be rotated and turned. We turn the collar so as to open and close the air hole. Okay? Now, this is crucial because depending on whether the air hole is opened or closed, you will have two different types of flames. So now, after labeling the parts of the Bunsen burner, let's look at the two types of flames which will be produced by a Bunsen burner depending on whether the air hole is opened or closed. Now, the two flames are known as luminous flames if the air hole is closed. So closed has an L in it. Closed luminous flame. On the other hand, if the air hole is open, it's non-luminous. Alright? Now what is the difference between closing and opening the air hole? If the air hole is closed, that means less air enters the burner. What did we say was present in air just now? We said that air contains oxygen. There's less oxygen for burning as a result of closing the air hole. So you can imagine, if there is less oxygen for the burning to take place when the air hole is closed, then the burning is not as good. What does it mean to say the burning is not as good? It means the temperature of the flames will be lower. So the luminous flame has a lower temperature. So in other words, starting with L, luminous, lower temperature, closed air hole. On the other hand, when the air hole is open, there is more air, more oxygen entering the burner. As a result, there is more oxygen for burning, and so the non-luminous flame, when the air hole is open, has a higher temperature. Okay, it's hotter. And this is the reason why, for heating in the laboratory, we will use the non-luminous flame. Next, soot formed. Because the air hole is closed, there's not so much air entering, there's not so much oxygen, and therefore the burning is not good. The burning becomes very sooty. It's a sooty flame produced. Alright, for the luminous flame. So what it means is that the luminous flame actually produces a lot of black color particles called soot after the burning happens. On the other hand, the non-luminous flame is clean. It burns cleanly because it doesn't produce any soot. It doesn't produce any sediment at the end of burning. And this is as a result of more oxygen entering the burner, and so it burns more cleanly. The next major difference between luminous and non-luminous flames is the color of the flame. Now, the luminous flame is called luminous because the flame can be seen easily. The flame is seen easily because the luminous flame is yellow-orange in color. Okay, it's easily seen, very visible. On the other hand, the non-luminous flame is not so easily seen. Okay, the color is fainter, is paler, because the color is blue. Okay, some books might describe it as blue-purple, but generally speaking, the non-luminous flame can be seen as a blue color flame. But the blue is not a very visible blue. The blue is actually a very pale blue. As a result of that, it's not easily visible. And that's why the non-luminous flame is called non-luminous. It's not very bright. It's very pale, very light in color. Now, finally, steady flame. Steady flame means whether it holds vertically or does it flicker around. The luminous flame is unsteady and flickering. Again, this is a result of the air hole being closed. Because the air hole is closed, there's not so much oxygen for burning, and so the burning, the flames itself, will be unsteady and flickering around. And this is why the luminous flame is not used for heating as well. The luminous flame, firstly, temperature not so hot, not good for heating. Secondly, the luminous flame is unsteady and flickering. Hence, if you use the luminous flame for heating, it could be more dangerous because it flickers around and it could actually burn the experimenter's hands. On the other hand, the non-luminous flame is steady, meaning it will not flicker left and right. It will just be vertical throughout the experiment. And that's also one of the reasons why the non-luminous flame is used for heating in the lab. Next, we need to know the steps involved, alright, in lighting a Bunsen burner. The first step is to close the air hole. We must ensure the air hole is closed before doing anything. Okay? Next, we switch the gas tap on. You can say open or switch on the gas tap. Alright? After switching on the gas tap, the gas will go through the rubber tubing to the barrel. Okay? So this is where we light the Bunsen burner. With a lighter. And where should the lighter be placed? The lighter should be placed on top of the barrel. Okay, so we light the Bunsen burner by placing the lighter on top. On top means this point here, in red color, on top of the barrel. Now, after the flame is lit, remember the air hole is closed. Air hole closed, luminous flame. But we want the non-luminous flame. If you want a non-luminous flame, you will now open the air hole to obtain non-luminous flame. So these are the quick steps to light a Bunsen burner. Remembering the first step must be to close the air hole first. Now, the Bunsen burner is an important piece of apparatus. You need to know how to label the parts of a Bunsen burner. You also need to know the differences between luminous and non-luminous flames. Of course, the steps involved in lighting a Bunsen burner, you should have tried this in the lab as well. Now, besides the Bunsen burner, other pieces of apparatus are also equally important. For instance, we have test tubes. We have boiling tubes. So the difference between a test tube and a boiling tube is the size. Boiling tubes are larger, so boiling tubes can contain more chemicals inside them. So let's say if I wanted to have 10 cm cube, 15 cm cube of water in and heat it up, I will usually use a boiling tube to heat up the water because 10 or 15 cm cube is a lot. Next, we have our measuring cylinders. Measuring cylinders measures volumes. So let's say if I wanted to measure 15 cm cube of water, I would use the measuring cylinder to measure 15 cm cube. Okay? We also have apparatus like the evaporating dish. The evaporating dish looks like that. The evaporating dish, as the name suggests, is for you to evaporate away some solutions. So for instance, if you have salt solution, alright, you will pour the salt solution into the evaporating dish to be evaporated to dryness. The evaporating dish needs to be placed on a tripod stand. So the tripod stand supports the apparatus over a Bunsen burner. So you put the tripod stand and the evaporating dish over the Bunsen burner so that the Bunsen burner's heating, the flames, could actually help to heat up the solution and evaporate it away. So these are some common apparatus that you find in the lab. You need to be familiar with how to draw them. Now, one good place to revise this drawing of apparatus is actually in our chapter 4 revision video. So in chapter 4, we go through the separation techniques for different mixtures. Evaporation to dryness is one of the techniques. So please revise the chapter 4 video if you have forgotten what is evaporation to dryness and how to draw the apparatus set up. Okay, and that brings us to the end of the first video for chapter 1. So we have revised Bunsen burners and the apparatus. Alright, thank you.